I'm Chandrakala, Associate Professor, Department of Mathematics, Aurora's Degree and PG College. Here I am presenting a paper entitled A Comparative Analysis for the Solution of Unbalanced Transportation Model by Various Methods. This is the framework. The transportation problem has been studied in a number of fields as a key feature. As such, in real life, it has many applications in computation of many problems. Here in our paper, an enhanced one suffix method is approached in this paper to solve unbalanced transportation problem, and we compare these results with other various methods. With the numerical examples, we have explained very clearly. It is very simple, understand, and easy to implement. This is the formulation of transportation problem. There are O1, O2, and so on, OM, M origins, and D1, D2, and so on, DN, N destinations. Our objective is to minimize the total transportation cost. This is the transportation table. The history of the transportation problem dates back to 1941 when F.L. Hitchcock suggested transportation of commodity from various outlets to different locations. Later, it was evolved further by Koopmans and Dadging. The simplex method is not suitable for transportation problem. So in 1954, for efficiency reasons, Churns and Cooper invented stepping stone process. Later, northwest corner method, row minima, column minima, matrix minima, Gill's approximation, many other methods have identified, and these are all initial basic feasible solutions. To obtain a convenient, viable, and optimal solution, Sudhakar et al. Presented zero suffix method in the year 2012. In our paper, we have approached one suffix method. The methodology is like this. We divide each row and each column by 1 so that each row and column has at least 1. And next we find the suffixes for all ones using the formula S is equal to sum of non-one cos in the ith row and jth column by number of ones in ith row and jth column. And next, in the next step, we check highest suffix value of 1, and we give allocation to the one which has highest suffix value. So we delete that row and column with the supply and demand is allocated for the cell, and we continue this process until all the supply and demand is exhausted. Here I am giving with explain with one example. Here we have 3 warehouses and 4 customers to supply. This is the demand 15, 19, 13, 18. These are the demands, and supply is 20, 28, 17 from for first warehouse, second warehouse, and third warehouse. Here, sum of the availability is equal to sum of the requirement. So that is equal to 65. This is the balanced transportation problem. When we apply VAM method, we get the cost of transportation problem is 236. If we apply zero suffix method, we get 209 rupees for the total transportation cost. If we apply our method, enhanced one suffix method, we get 209 rupees total transportation cost. This is the second example. Here we have 3 open hearth furnaces and 5 rolling mills for the steel company. And the cost of transportation is shown in the following table. For shipping the steel from furnaces to rolling mills, we need to find optimal shipping schedule. Here, when we see the problem, total requirement of mills is 30 rupees and total capacity is 34. This is unbalanced transportation. So, to convert this problem into balanced, we introduce a dummy fictitious mill M6 with 0 cost, and the requirement is 4. Now it becomes balanced. When we apply VAM method, we get 80 as a net cost of transportation problem. If we apply our one suffix method, the total transportation cost is 80 rupees. So here I am giving the comparative study. For the first problem, for the first example, the optimum value is 209, and the number of iterations for VAM method is 6, and in VAM method, VAM means Vogel's approximation method, the transportation cost is 236, but the optimal solution is 209. That means it is not the optimal solution. It is initial basic feasible solution. When we apply zero suffix method, we get 209 with 4 iterations. When we apply enhanced one suffix method, we get 209 with 4 iterations. And for the second example, optimal value is 80 rupees. In VAM method, we get 8, but the number of iterations are 6. For the same problem, if we apply zero suffix method, we get 80 as optimal solution with the 5 iterations. And one suffix method, if we apply, we get 80 with the 5 iterations. That means this our method, proposal method, is very easy and convenient method. In this paper, we proposed a different approach to find an optimal solution to an unbalanced transportation problem. With the help of numerical examples, the solution of this method is explained and tested with an optimality test. The technique is suggested here. It is very basic, easy to understand, and easy to apply. Thus, the proposed approach will help decision makers to deal with transportation problem of an unbalanced type arising in real life situations and have an optimal solution. These are the references I have applied. Thank you.